This video is about adding displacement vectors and features a duck. In this video, 4 studs is equivalent to 1 metre. The duck in question can swim at 1 metre per second. A river is flowing due west at 2 metres per second. If the duck tries to swim south across the river, where does the duck end up? To answer this, we need to think about adding vectors, which we do by drawing them head to tail. We also need to know the width of the river, which is 2.5 metres. As velocity equals displacement divided by time, we can calculate that it takes the duck 2.5 seconds to swim across the river. In this time, the river has moved 5 metres. So the duck has travelled 5 metres west and 2.5 metres south. To find the magnitude of the displacement vector of the duck, we can use Pythagoras' theorem, which states that the sum of the squares of the 2 perpendicular sides of a triangle equals the square of the hypotenuse. From this, we can calculate that the duck has travelled a distance of 5.6 metres. To find the direction the duck has travelled in, we need to find the angle theta, which we can do using trigonometry. I will use tan rather than sine or cosine, as we know the length of the sides adjacent to and opposite the angle theta exactly, whereas our value for the hypotenuse was rounded to 2 significant figures. So theta is the inverse tan of the opposite side divided by the adjacent side, which gives 27 degrees. However, when dealing with directions like north, south, east and west, it's conventional to give a bearing measured clockwise from north, so we can subtract 27 degrees from 270 degrees and say that the duck has travelled 5.6 metres on a bearing of 243 degrees. So in summary, when adding vectors, draw them head to tail, use Pythagoras' theorem and trigonometry to calculate distances and directions, and never feed ducks bread as it is bad for them. Thank you for watching.